G'day. Today's lesson is going to be on dot plots and stem and leaf plots. Now, the thing with dot plots and stem and leaf plots is they're just basically ways of organising data, which is pretty much all we're doing in this topic. But for every different type of data that you get, there's the best way of representing that data to other people. Now, if I have a look at these two sets of numbers here, the first set of number, 2, 2, 3, 3, 4, 4, 5, 6. We notice that these numbers are actually really, really close together. Because these numbers are really close together, we can use what we call a dot plot to represent these numbers. And by that I mean, all it effectively is a line that we draw, and we mark, I'll just mark it at centimetres, 1, 2, 3, 4. Way too big than what it needs to be. Use my rubber. And if I wanted to represent these numbers here, all I would do is represent each number as a dot on the dot plot. So there's a 2, I put a 2 here. There's another 2, I put another 2 here. Best cross them off as I go. 3, another 3, 4, another 4, 5 and 6. And there I have that data represented as a dot plot. I should always put a title and units down the bottom, or an axis title down the bottom. But what I'm trying to get at is this type of data is really, really good for numbers that are close together. The problem with dot plots is that or should I say the benefit of dot plots is that they're really, really simple, but if I've got a set of data which is slightly different, in other words, 21, 32, 23, 47, 65, 53, 41, we see that with this set of data, they're not close together. If I was going to do a dot plot for this, the dot plot would be really, really, really wide, and there would be a dot here, there'd be a dot here, there'd be a dot here. It's all very, very sparse. And so a dot plot is not the best way to represent this data here. So for this sort of data that we see, that there's a common tens, or at least the tens are grouped together, we can use a stem and leaf plot. And it doesn't have to be just the tens, it can be the hundreds, the thousands. Basically, if there's one of the places in the numbers that are fairly close together, we can represent them in a stem and leaf plot. And a stem and leaf plot is special because we effectively have a stem oops, I can spell leaf, beg your pardon. We effectively have a stem which we can make the tens column. Imagine like the stem is the tens column and the leaves are all the units. And the leaves can vary, but the stems remain the same. And we see the stem here is, we go from 2, 3, 4, 5, 6. So we can say 2, 3, 4, 5, and 6. And the leaves are the units. So as we go, we say, well, this score is 21. So it starts with a stem of 2 and a leaf of 1. Cross it off. 32, it starts with a stem of 3 and a leaf of 2. 23 is a stem of 2, and now that we've got another score, we put a comma, and we've got a leaf of 3. Now this is a little bit tricky because I'm sort of going ahead, but with stem and leaf plots, the only trick with them is that they're usually ordered. They're usually referred to, as ordered stem and leaf plots, but they're always in order. So the stem, you'll see it's 21, 23, and the leaves go up, they ascend in ascending order. The biggest mistake most people make with their leaves, in this case I've got 47 and 41, they would put 47 and then 41. Now this isn't going up in ascending order, so we'd have to replace that, switch that around, make that 41 and 47. So what happens a lot of the time with stem and leaf plots is that people do one and then they do another one which is ordered. So we've sorted these two out. Now we've got 53 and 65. Now, as I said before, it doesn't have to be just the tens column. It can be any column. If I put 0, should I say, that's probably not a good example. If I put a 1 in front here of all of these numbers, we still see that they're grouped together. That's 121, 132, 123. My stem would be 12, 13, 14, 15, 16, because that would be our stem as we go along. The stem can be any set of numbers, but providing that they're sequential in order. And so what we see, the difference between our dot plots, is our dot plots, the scores are all close together, whereas our stem and leaf plots, the scores are all fairly spread apart, but there is a common stem throughout. So, to summarise basically what I just said, here we have nice printed examples of a dot plot, age of children a function, and age in years, and we see that they're all nice and closely related, 1, 2, 3, 4, 5, 6, and then there's 10. And then here we see with the stem and leaf plot, we've got scores of 71, 73, 75, right up to 104. Now, if we were going to do a dot plot to represent this data here, it would need to go from 71 all the way to 105. So we'd have to have 34 spaces or 34 units long. So we'd have to basically do the whole page. And that's just a really impractical thing. Now,